Excuse me for a second, I just have to get stuff set up. But to give everyone a rundown, I'm doing two sort of parallel tests here. So I'll be using scopes to show the time delay based off my signals here at the microphones, and then I'll also be showing my program in the microcontroller doing the same measurement. So at this point, I will begin the demonstration. And it has to build, so I'll give you a rundown. So again, at this point, I'm testing with this Cruder setup, and that is this hammer with a lead attached to it and this copper plate. Eventually, I'll integrate this slide hammer seen over here into the setup, and I will slide in and attach to this. I guess it's all issues. Hold on just a second. At this point, my program developed issues, so I can demonstrate the time delay in the scope. So everyone can see this yellow lead on this first scope is the trace off the hammer contact, and so you can see it drives down. The scale here is 250 microseconds per division, so that means if you're able to see these dotted lines, each one of those blocks across is 250 microseconds. And well, that's and so you can see that there is a small delay between the drop of the hammer to the first microphone. And open up for additional questions. So the microphones are contained within this 3D printed piece, and so this is the first microphone and this is the second microphone.
And I guess those extra square waves are just because you're moving the hammer back after you tap into some other experience
Right.
stuff.
So
there's a
there's
delay there.
a lot of stuff that can be cleaned up in this testing apparatus. So when I hit this board will rock, and there's a lot of variables that need to be constrained.
What is the hammer? Can you show the hammer?
Sure.
So that's the actual, that's what you designed in the system.
So this is a slide hammer, and so all it is a slug with a rod attached. At this point, I'll just be attaching the lead up here in the shaft collar, and the bottom of the metal mesh, and that's what we'll make contact with. And the hope is, in using that metal mesh, it'll transmit sound better to the concrete, so you get more similar transfer of sound than you would through traditional hammer-on concrete contact.
Did you find out that the weight of the hammer is critical?
Not at this point. It's really the range. So I've done a little bit of testing myself, and it doesn't make a ton of difference. And again, the tests done, the the traditional hammer sanding tests are all done without any sort of quantification, so you're just listening for a thud or a ring. So at this point, I haven't found any difference, but additionally, I haven't had a need to test that specifically yet.
And with the sounds, and the timing of the sounds, what kind of results are you looking for as far as good concrete or bad concrete? What would you be able to prove? What would be the criteria for good or bad?
So bad concrete would tend to take longer for sound to travel through it, and in showing that it would take longer for the sound to travel through, with more data, I'd be able to provide that, I know that I've determined that the thickness is this much here. I know that it should be taking about this standard time to get through it, but it's actually taking longer, and you can make some interpretation of the quality of the concrete that way.
So come up with a standard time, you need to establish what that is.
Right.
Have a way to calibrate it or what to know when good timing,
Yep.
based upon the thickness.
Correct. Sean, question?
I was just gonna see if you could mention, so what do you do with those signals? Because I know you do something with those signals. To get a time delay, do you have other parts of the project that actually handle those signals and then spit out a time delay? Where does that all occur?
So the measurement in my software, which is having issues right now, is done within that microcontroller. And so all calculations and measurements are done within that microcontroller. At this point, the data is outputted to the PC. Eventually, it'll be displayed on an LCD screen, and everything will be battery powered.
So the Kinetis board has what, a couple of A to Ds on it, or?
Yeah, I think I can have up to 8 channels, but I'm using 2 right now.
So each microphone is going into its own channel, and then you're detecting the rising edge, or?
Correct. Any other questions?
What's the speed of the counter on the resolution of the time?
25 microseconds at this point, eventually.
Of the clock frequency?
It's actually based off of the A to D speed. And so at this point, I'm using a software timer. Eventually, I'd like to use a hardware timer and be able to get a little bit more speed out of that. Or resolution, I guess, would be more precise.
Is the absolute timing that important, or is it the relative timing that is what makes the algorithm work?
Well, I mean, I need to know a certain resolution. Right now, if I'm measuring a, say 200 microsecond time delay, I can divide that up into 8 because it's 25 microsecond steps. And that's okay for proof of concept. I think in the future, I prefer higher resolution. If I have, that's a pretty small division of 8. So if I have a second time delay, which comes out as 225, I've just got that one blocker resolution, so it could be an error at that resolution.
All right, great job.